6.3, whoop, 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 whoop. Oh yeah, you're excited. I know. So when we have binomial radical expressions, binomial, remember that means two terms. Radical, that means that radical sign, expressions, no equal sign. That's what this heading means. We can only combine radicals if what is underneath the radical is the exact same and the index is the exact same. If that's not the case, you cannot combine. So we're like radicals with just numbers, so I can combine these two because there's like a 1 in front. So 1 plus 3 would give me 4. The radical does not change. Again, here's my cubic. The exact same is like 1 minus 5 would be negative 4. You can also do it to make sure that underneath the root has the exact same variables. Again, it has to be the same in order to do it. So this is like 1 plus 8 gives me 9, or 1 minus 8 gives me negative 7. So that property is the same. We'll get back into this. So when I'm looking at this right here, I can only combine if they're the exact same. Since this radical is the exact same right here, it's the same thing as if this said 3x minus 2x. It's the same concept. So I take 3 minus 2, and I have 1. And then that square root stays the exact same. When I'm looking at these two, my roots are not the same, and neither are my variables. So I cannot simplify this. So can't simplify because the roots are not the same and the variables also not the same. So that doesn't work. When I look here, this root looks the exact same. However, when you look at this index here, those are not the same. So I can't simplify. Okay. However, if they look different like these do, what I first have to do is simplify each term. I personally draw this line here so I know that I can't go in between. I do not multiply these. I have to simplify this. So I'm going to do my factor tree. 4 times 3, 2 times 2. No number. Remember, that means that there's a 2 out in front. So I'm looking for groups of 2. So one group of 2 that comes outside of the root. And I'm still left with this square root of 3. If I look at 75, so 25 times 3, 5 times 5. Here's a group of 5. I still have adding here. So a 5 comes out because there's a group of 5s, and this 3 is left inside. This is prime. I can't simplify that any further. Now they all look the exact same. So now I can do 2 plus 5. This is take away 1. So 2 plus 5 is 7. Take away 1 would give me 6 square root of 30. This one's a little bit different because if you notice that the index here is 3, it's not 2. So I'm still going to do my factor trees. Now I'm looking for groups of 3 because it's cubic. So here's a group of 3. This is what's left over. This 5 comes out of the radical because there was a group of 3. I'm still left with the cubic root of 2. Here's a group of 3. So again, this is adding here. So I have plus. That 3 comes out. I'm left with this 2. Here's a group of 3. So subtraction. So that 2 comes out. Cubic root of 2. So now they're all the exact same. So now since they're all the exact same, I can do 5 plus 3. So it's only the number in front. 5 plus 3 is 8. 8 minus 2 would give me 6. This cubic root of 2 does not change. That does not change. When I'm multiplying, look at this. I'm still going to do first, outside, inside, last. If you prefer to do it the box method, you definitely can do that. But I'm going to go first, would give me 20. Outside, when I multiply, this is a whole number times a whole number. So those are the two numbers that get multiplied. So I have a plus 16, and I still have the square root 2 at the end. At my inside, so I look at the 2 times 5 would give me 10, and I still have that square root 2 at the end. Now when I do my last, this is where I have to be careful. The 2 times the 4 get multiplied, get 8. Now both of these square roots have to get multiplied. So square root 2 times square root 2 would give me a square root 4. Now I can simplify this. These both have square root 2's. I can combine them because it's the exact same root. So I have 20 plus 16 plus 10 would give me 26 square root 2. I can rewrite this as 8 because the square root of 4 is 2. This number becomes 16. I now can combine those two together. So 20 plus 16 would give me 36 plus 26 square root 2. You should try to do this next one by yourself. So I FOIL. This was my first, my outside, my inside. This is like a -1, so that's why this is a -5. And my last. Square root 7 times square root 7 is 49. So still these two middle terms get combined. I have 15. This is 3 minus 5. Give me a -2. That square root 7 stays the same. The square root of 49 is 7. So now these two can be combined. 15 minus 7 would give me 8. 2 square root 7. When you're writing this, you should have your whole number first and then your root number. So here, now I'm going to be multiplying by my conjugate. So my conjugate is basically same two numbers inside the parentheses. It's just opposite sign in between. So if I multiply this at my first, my outside, my inside, and my last. So first, outside, inside, last. These two combine together. This would be a positive 5 minus 5 square root 7. So those two actually completely cancel. I'm left with 25. This simplifies to just 7. So 25 take away 7, give me 18, and that's my final answer. Try to multiply the next conjugate by yourself. First, outside, inside, last. Okay, you multiply only with the roots that are together. Again, these two cancel. Oh, interesting. This becomes 36. This becomes 12. The square root of 144 is 12. So my answer is 24. What is the conjugate? So when you're looking at a conjugate has a binomial with same numbers, but opposite signs between. So like x plus y, x minus y. Same numbers, opposite side between. Why do we multiply by the conjugate? Always cancels the radical. And both of these, the radical was completely gone. I just get a whole number. Whole number answer. Why do we have to multiply by conjugate? It's because if we have to rationalize the denominator, oh my gosh, this is going to be hard. No, it's not. You can do it. I believe in you. When you want to rationalize the denominator, you do not want these in the bottom of your fraction. So in order to get rid of those in the bottom of the fraction, you only focus on the bottom. You want to multiply by the conjugate. Remember, the conjugate is the same two numbers. So same two numbers, opposite sign. If this is subtraction, this has to be adding. Now, this is the exact same on top and bottom. I'm actually just multiplying by 1 then when you have the exact same on top and bottom. So I can multiply this here and here. I'm going to write my division bar. So 3 square root 2 times square root 5 would give me a 3 square root 10 because you multiply the 2 and 5 together. Next, 3 square root 2 times square root 2 gives me 3 square root 4. On bottom, if I do my first, outside, inside, last, my first would be square root of 5 or square root 25 when I multiply those two. My outside would be the square root of 10. Inside would be the square root of 10. And my last would be a negative square root 4. Now I have to simplify stuff. Square root of 4 is 2. So this would become 3 times 2, which is equal to 6. Square root of 25 is 5. Square root of 4 is 2. So this is a negative 2 because of that subtraction. These two cancel each other out. It's a positive and a negative. So on top, I'm left with the 6 plus 3 square root 10. You should have your whole number out in front. This gives me 5 take away 2. It gives me 3. At this point, you want to see if you can simplify even further. You have to look at this heart. When I look at this heart, all 3 of these terms, look how I do not include the root, all 3 of the terms can be divisible by 3. So this final answer can either look like this or just with that on top. I want you to pause and find out what the conjugate is of b and try to multiply through. My conjugate that you should multiply on top and bottom is 3 plus square root 6 on both top and bottom. So now multiply it through. When I multiply on top, 4x times 3 is 12x. 4x times square root 6 is 4x square root 6. Then my first, outside, inside, last. Now when I simplify this even further, this becomes 6. So this becomes subtract 6. These two cancel. I have 12x plus 4x square root 6 over 9, take away 6 is 3. When I look at these three, just the 12, the 4, and 3, there's nothing that they have in common. So I'm going to leave my answer just like that. You could, if you wanted to, split it up like this. And then that was simplified to be 4x, because this can simplify, plus the 4x square root 6 over 3. This answer is the same as this answer, just simplified a little bit more. What are the steps to rationalize in the denominator? First step, multiply, that's by, conjugate on top and bottom. Multiply by the conjugate, multiply by the conjugate. Second step, I'm going to simplify radicals, like here, this radical, here, this radical, over here. Third step, you want to combine like terms. So usually these two cancel out. If there's any place else that you can combine like terms, you should. And my last step is to look, that's funny eyes, for the heart to see if you can simplify the fraction. Simplify fraction. And that's it. That's all we got for 6.3. Congratulations, we made it through this chapter. Have a great, grand, wonderful day.